Okay, so let's look at this problem. And I apologize because there's a air conditioner kind of blowing over my shoulder here, but I think you'll be able to hear all right. All right, so we've got this hypothesis test, and we're told that alpha is 0.05. Our null hypothesis is that the mean is 63.1, and our alternate is that the mean is not equal to 63.1. Now this alternate tells us this is a two-tailed test because we have a not equal to sign here. All right, so let's proceed with all the steps we need to go through. You believe the population is normally distributed, and you know the standard deviation is 19.1, and of course it uses the population standard deviation. So since we know it's normally distributed, and we have the population standard deviation, and if we look at the sample size at 64, we're going to be able to use the z distribution for this. And then we have a sample mean of 68.1. All right, so let's start with the critical value. For the critical value, we will only use alpha. All right, so since it's a two-tailed test, we are going to divide alpha by 2. If we divide alpha by 2, we get 0.025. And I'm going to go to Excel, and I will put, and I already stuck it in, but I'll do it in again, equal norm.s.imv 0.025, and we get, that's our critical value. Now, we have to be careful because it can be both positive and negative with a two-tailed test. And let me find our original here. Oh, that's not it. There we go. And this already has the positive and the negative there. So we just want to put it in as the positive value since both the plus and the minus are there. So just be careful of that, about that, since it's already got the signs out here. All right, now let's go to test statistic for the sample. Our test statistic is basically our z-score, but we want to use the z-score that takes the sample size into account. So we're using the sampling distribution z-score. Okay, so let me write these values down real quick, and then we'll switch over to a sheet of paper to work them out. Actually, I think I can do it right here. Let's see. Yeah, okay. So we'll have z equal, we want our sample mean first, which will be 68.1. I apologize, I'm writing with a mouse, which is rather slow. And then I want my population mean of 63.1. And then I'm going to put that over the standard deviation of 19.1 over the square root of the sample size, which is 64. Okay, so we want to work this out, and that will give us our test statistic. So I can tell that the top is going to be 5. I will take a moment and put the bottom into my calculator, all of this. And you do want to be careful that you put this in parentheses as you put it into the calculator. And as I exited out to actually stop the video while I pulled out my calculator, it erased everything. So what we had was 5 on top, and then we had the 19.1 divided by the square root of 64 on the bottom. And I'm actually out here without a calculator, so I used Excel. So let me pull that value from where I used it. Oh, I see, okay. 2.3875. 2.3875. Alright, and let's put that into our calculator. And again, unfortunately, I will have to go to Excel, and apparently I have to leave this process as I go to Excel. So I'm going to stop the video while I work that out. So Z ends up being 2.094. That's what goes into our test statistic box. And in all of these hypothesis tests, depending upon what kind of hypothesis test we have, the test statistic could change. So that's the thing to keep in mind. All right, now, for the critical value, it was 1.96. And this 2.094 is to the right. So like if we think of a normal curve up here, and it's a two-tailed test, so we have a critical value here and a critical value there. And our critical value is going to be the positive value here and the negative value over here on the left. And if we have any value for our test statistic that either falls into this left tail over here or into this right tail over here, we will reject the null hypothesis. In this case, 2.094 does fall over here in this right tail. So our decision, well, first, it is in the critical region. And our decision is to reject the null when it's in the critical region. If we reject the null, that means we are embracing this alternate hypothesis. So there's enough evidence for us to say that the alternate hypothesis is true. So let's look down here for something that tells us that there's enough evidence to say that the mean is not 63.1. And it's a little faded, but see, the sample data support the claim that the population mean is not equal to 63.1. So looks like it's this third one here. All right, and hopefully that will help you with some of these. Now, the differences you're going to run into is if it's a greater than, you are not going to divide this by 2 to get your critical number. You would have 0.05 over here on the left, but when you put things into Excel, it always gives you what corresponds to the probability that's on the left, not on the right. So you would need to put 0.95 into Excel, and it would give you the critical value that would go right here. If this was a less than for the alternate, you just put the alpha in as is, because it's really looking at the little bit of area over on the left, and you get the critical value that goes right here. Otherwise, this process is pretty much the same for every single one of these. But if you run into trouble, just let me know.